morning, dear friends. Myself Sonigra, and today we will continue with the solution of GTU examination question paper in the subject of mechanical drafting. Previously we started the solution of GTU examination from exam July 2010, and today we will continue with further questions. Question number 2b, which is asked for 7 marks. The data is given like this: a cylinder diameter 50 mm and 70 mm axis is completely penetrated by another cylinder of 40 mm diameter and 70 mm axis horizontally. Both the axes intersect and bisect each other at right angle and parallel to vertical plane. Draw projections showing curves of intersection. In this data, 2 cylinders are given to us, vertical cylinder and horizontal cylinder. The diameter of both the cylinders are 50 mm and 40 mm respectively, and as the cylinder is having curvature shape, the curve of intersection would be curvature. It would not be straight line, but we have to join the points with a smooth curve. And 2 cylinders are given, hence first we draw the vertical cylinder of diameter 50 mm and height 70 mm, and after that the cylinder is penetrated by another cylinder, hence it would be needed to draw side view also. So we will draw side view also, and in side view the penetrating cylinder will appear as circle. So let me start the solution of the problem. The data is given like this. So from this data, this is the isometric view of given data. The vertical cylinder having diameter 50 mm and height 70 mm, and this red colored cylinder is a penetrating cylinder which is having diameter less than this vertical, that is 40 mm. So there is a difference in diameter, hence its curve of intersection would appear like this. This would be the curve of intersection. You can see here this one, this curvature shape. If diameter of both the cylinders are equal, in that case the curve of intersection would appear as a cross over here. So let me start drawing. First draw XY line, which represents intersection of horizontal plane and vertical plane. So draw XY line. Draw a circle below XY line, because the top view of this green colored cylinder would be circle having diameter 50 mm. So draw its axis like this: vertical axis, horizontal axis. Name the endpoints 1, 2, 3 and 4, and draw axis of the cylinder, vertical axis. Height is given to us, that is 70 mm. Now to draw its side view, let me draw here line at an angle of 45 degree and take projections from here like this. Projections from these ends 2 and 4. To draw this front view, we take projection from 1 and 2, and to draw this side view, we take projection from 2 and 4 on this side. Now these projection lines cut this 45 degree line at 2 points. One point is here, another point is here. So from these points draw vertical line, project them, and this would be the side view of this cylinder. So till now we have drawn 3 views of this green cylinder: top view, front view and side view. Name the endpoints, and then this is the side view of this red colored cylinder. If you look from the side view, this cylinder would appear as a circle having diameter 40 mm. So draw a circle having diameter 40 mm, and it is given that both the axes bisects each other, hence we need to find out the midpoint of this height. So 70 is the total height. So at a distance of 35 over here, mark a point, and from that point draw a circle having diameter 40 mm. After drawing this circle, divide the circle into equal number of parts. Say we have divided into 8 equal parts like this, and from this draw horizontal lines like this. These horizontal lines from end points of the cylinder, and length of the cylinder is given to us, that is 70 mm. So 35 mm from this axis on either sides, on both the sides, on this side as well as on this side. So this rectangle represents the front view of this red colored cylinder. As you can see, this red colored cylinder upper edge is there over here, which is inside this green colored cylinder. Hence, this edge from this end to this end, means from here to here, the edge will not be visible. Hence, we join them with the dotted line like this. So dotted line would be here, as well as here also dotted line would be there. Two dotted lines represents the upper edge and lower edge of this horizontal cylinder. And regarding these vertical lines from here and here, this green colored cylinder is cut over here by this red cylinder. Hence, these edges would not be there. It's cut portion. Hence, here vertical lines should be erased one. Now, after drawing this side view, let me draw its top view. So for that, let me take projections from its side view to this 45-degree line. From that, draw horizontal line like this, and this rectangle represents the top view of this red colored cylinder. Again, in top view, these two edges, the end edges of this red colored cylinder would be inside this green cylinder. Hence, inside this circle, the edges would appear as a dotted line like this, because the edges are there but it is not visible. Hence, we have drawn with dotted line over here as well as dotted line over here. After drawing this top view, let me find out the curve of intersections. So for that, we take horizontal lines like this. Now find out the point of intersection. So for that, let me take point number 1 or this point, say point number C double dash or B. From B, draw vertical line, horizontal line, and this line will cut this circle at this point, somewhere here. So from this point, draw a vertical line, and this vertical line and horizontal line from point B both will cut at one point. So this is the point of intersection. We solved numerous of problems of such kinds. So these would be the points of intersection you can see here. To locate this point, let me take this point. From G double dash, draw vertical line over here that will cut the horizontal line, this 45-degree line at this point. From that, draw horizontal line, and this line will cut this circle at this point, and from this point draw straight vertical line, intersection of this vertical line and horizontal line from G double dash, that is this point. So remaining points also can be find out with the same analogy. We may take vertical line and horizontal lines from rest all points A double dash, B double dash, C double dash to H double dash, and we can locate all these points on this side. Similarly, on this side also we can locate the points by taking intersection of these lines with these circles on this side. We have taken intersection of this side. Similarly, we can take intersections on this side also, and from that we can locate points of intersection on this side like this. Now join all these points with a smooth curve like this and this. So these two curves are these curves, which shows the curves of intersection between these two cylinders. Name the views. This is the final drawing. Front view, dotted line. So remaining all lines should be erased, or these lines should be lightened. Insert the dimensions. This is diameter 40, this is diameter 50, and height 70 mm, and width or length is 70 mm. All the dimensions should be inserted at least once in this diagram, and write the names of views. This is front view, this is top view as shown over here, and this view represents its side view. So name this is a side view. 3 views are there. So this is the final solution of the question. It is asked for 7 marks. So distribution would be like this: 2 marks for side view, 2 marks for top view, and 3 marks for front view, because in front view points of intersection are there. So 2 plus 2 plus 3, total 7 marks are there of this question. So I hope the solution of this question is clear to you. Now next problem. The data is given like this: a square prism, 30 mm base sides and 70 mm axis is completely penetrated by another square prism of 25 mm sides and 70 mm axis horizontally. Both axes intersects and bisect each other at right angle. So here square prism is given. It is penetrated by another square prism. 2 square prisms are there, and all faces of prisms are equally inclined to vertical plane. Means we have to draw its front view and top view in such a way that all the faces of the prism should make equal angle. So for square prism, that angle would be 45 degree. Draw projections showing curves of intersection. As both are prisms, the curve of intersection would be straight lines in some ways. So we have to join the points of intersection with the straight lines in this case. So first, the given data is like this. It's a square prism type problem, and its isometric view would appear like this. This is a square prism, vertical square prism, and bisecting square prism. This is the curves of intersection or lines of intersection. To draw solution of this problem, let me draw XY line that represents intersection of HP and VP, and draw square prism below XY line like this, because top view of this prism would appear like this, and angle of the sides makes equal angle with XY line. It is given in the data. So it should be drawn like this. This line makes an angle of 45 degree with XY line. Name the endpoints 1, 2, 3 and 4, and from these points draw straight vertical lines. Height is given to us. So according to given height, that is not given in this data, so we assume any convenient height and draw its front view. In front view, it would appear as a rectangle. This edge would be visible as shown over here. This edge is visible, and these edges are the endpoints of this square prism. Now to draw side view of this prism, let me draw line at an angle of 45 degree and take projections from 2 and 4 on this side, and from there draw vertical lines like this and project lines from here. So this is the side view of given prism. So these three views we have drawn of this prism. Now draw side view of this prism. In side view, this horizontal prism would appear like this, a square which makes an angle of 45 degree with XY line, and at the midpoint of this axis. Total height of axis is not given, so we assume any convenient height, and at the midpoint mark a point over here, and from that draw horizontal line and vertical line and draw a square such that all the sides makes 45 degree angle with the XY line. After drawing this side view, let me name the endpoints and draw its front view. Name endpoints A dash, A double dash, B double dash, C double dash and D double dash, and draw horizontal lines from A double dash and C double dash, D double dash, and then take any convenient width or length of this prism and draw a rectangle like this. So this rectangle represents the front view of this prism. Now to draw its top view, let me take projections from front view like this, vertical lines from here where it cuts the 45 degree angle line at these points. Here also draw vertical line from here, it cuts 45 degree line at here. Draw horizontal lines from both these and draw vertical lines from here. So this gives the top view of this prism. Now to find out points of intersection, name the points 1, 2, 3 and 4 and so on. Now the points of intersection would be here. Let me take this point. From D double dash, draw vertical line and horizontal line, and this line will cut the square 1, 2, 3, 4 at this point. So pick up this point, and from this point draw straight vertical line, and the intersection of the vertical line from this point and horizontal line from D double dash, this is the one point. So that is the point of intersection between these two prisms. That is this point. We have located this point over here. Next, on this side, this point is also there. So to find out the point of intersection of this point, let me draw this point from here, or line from here, and this line will cut the square at this point, and from there draw vertical line. So intersection of this vertical line and horizontal line from D double dash, these are the 2 points that we have located. Now regarding these points, so for that similar analogy to be employed, intersection of this point. So from here draw straight vertical line and horizontal line from A double dash and C double dash. So these are the 2 points on this side. Similarly, 2 points on this side. So 4 points we have located over here. Join all these points with a straight line like this, A dash to B dash, B dash to C dash, and here also straight line. So these 2 straight lines represents these intersectional lines. The plane of intersection is this, and this is the intersection line that we have shown over here. And this edge, horizontal edge of this penetrating prism is inside this vertical prism. So here in this portion, dotted line would be there. So let me draw that. And here also this edge, upper edge, which is inside this prism, so it will not be visible, hence drawn by dotted line like this. So this is dotted line, this is dotted line, and this intermediate is also dotted line. So it should be drawn like this. This dotted line, this and this, and rest all lines should be either made much lighter or they should be erased. So this edge, upper edge of this horizontal prism is shown by this dotted line over here like this. And so name the views. This is front view, this is top view, and this is side view. So this is the final solution of the given problem. Asked for 7 marks. So here also distribution would be like this: 2 marks for side view, 2 marks for top view, and 3 marks for front view. If you do not draw this curves of intersection, you will lose just 3 marks. Even if you draw just side view and top view, you may at least get 4 to 5 marks also, which is much easier to draw this solution. I hope this solution is clear to you. Now next problem, question number 3a, asked for 7 marks. Data is given like this: a pentagonal pyramid, 30 mm base side and 50 mm axis, is standing on horizontal plane on its base, whose one side is perpendicular to vertical plane. It is cut by a section plane 45 degree inclined to horizontal plane and perpendicular to VP through midpoint of axis. Draw front view, sectional top view, and true shape of the section. So here pentagonal pyramid is given to us. Base side is 30 mm and height is 50 mm. It is standing on horizontal plane. As it's standing on HP, its top view would be square, would be pentagon because it's a pentagonal pyramid, and its front view would be triangle because it's a pyramid. Now it is standing on HP on its base, whose one side is perpendicular to VP. So we have to draw its top view such that one side of the pentagon should be perpendicular to XY line. It is cut by a section plane. We have to cut this pentagonal pyramid by a section plane which makes an angle of 45 degree with horizontal plane, means with XY line, and passes through the midpoint of the axis. So axis